name's Olly. I'm a cloud native security engineer at a company called Control Plane. We turn on the clicker so that it works. Yep. We're cloud native security specialists, so we do a lot of work with Kubernetes, containers, pipelines, generally things in the cloud, but also cloud native things that are running on-premise. We have a lot of clients that are in highly regulated environments like financial industries, government departments, things like that. And there's about 50 of us. Our headquarters are in the UK. We've recently, this year, opened an office in New Zealand, so there's a few of us around from the New Zealand office. And yeah, rapidly expanding. We've also opened an office in New York recently, so slowly taking over the world. Cool. So I'm going to be talking about keeping secrets secret, a bit about secrets management. We're going to talk about why we want to protect our secrets, if it's not clear from the name. The goals of managing secrets, the sort of path that I see a lot of teams taking to improve their secrets management processes, and a bit of a developer perspective as well on some of the secrets management processes and what that looks like from a developer experience point of view. Hopefully, you'll have a better idea of some of the considerations of secrets management, and I'm going to reference some tools and resources. There'll be links at the end. There's a QR code at the end with the slides to all the resources, so that'll be easy. And yeah, just in general. I'm going to give this one. Oh, awesome. Thank you. Hey, now I can walk around. And can you still hear me? Yes. Awesome. And generally improve security, because with hacking in the name of the conference, that's what we're all here for, right? Awesome. So what are secrets? Today I'm going to talk about machine-to-machine secrets. So I'm not talking about users with passwords or MFA, but if you are a user, you should be using passwords and a password manager, and hopefully turning on multi-factor authentication everywhere. But today we're just going to be focusing on servers talking to other servers, talking to APIs, databases, that sort of thing. So it might be passwords, it might be TLS certificates, mutual TLS, API keys, tokens, whatever it is. If it's two servers somehow authenticating so they can talk to each other, that's what we're talking about. Why is secrets management important then? Well, it is sort of in the name. It's a secret. It's something that we want to keep secret. But there are a few, there's a few reasons, there's a few lists and things. So I'm a big fan of the OWASP top 10. Two of the OWASP top 10 sort of reference making sure that you keep your cryptographic material and your API keys and things like that secure. It's also in 5 out of the 10 OWASP proactive controls for securing your applications. If you're more of a MITRE attack framework fan, then there's also quite a few. I've just picked out a couple. There's almost 1,000 CWEs now, so I didn't read through all of them. These are just a few that relate to making sure that you keep those passwords and API tokens and TLS certificates secret. So yeah, it's some people smarter than I have created lists of things that include keeping your secrets secret. Just taking a step back and thinking about information security in general, in my mind, the goals that we have as information security professionals sort of boil down to 3 things. Reducing the likelihood of something being breached, reducing the impact when something does get breached, and being able to hopefully identify where that breach came from. Maybe not who did it necessarily, but which part of the system was compromised so that we can make sure that we don't get compromised in the same way again. Thinking more specifically about the goals of secrets management, I've taken the OWASP secrets management cheat sheet. So the OWASP cheat sheets is a great resource for all sorts of security related things. People have put together these cheat sheets that list out the things that you should think about when you're doing different information security things, and one of them is secrets management. And I've taken the 12 things that they have in there and divided them up into sort of 3 parts. And the first one is foundations. The second one is sort of the core goals, and then the advanced goals, which are once you've got those core things down. But first, I'm going to introduce another concept, which is the path of improvement. Like I said, this is how I see a lot of teams go from bad secrets management to better secrets management, and there is a road to improvement. People don't generally go from hard-coded secrets to whiz-bang, everything is amazing. You know, there's a progression there because it takes time and effort to implement those things. So on the left-hand side, we have hard-coded secrets. Plain text passwords in your code, in GitHub. And it's terrible, and it's kind of a bit like raw chicken. You know, you don't really want that sitting on your desk because, you know, that gets gross real quick. And from there, we move to the right. So we move forward and we improve things, and hopefully we get to a point where we are doing things in a way that's not gross and icky. So just in case we weren't clear on what I mean by plain text passwords, hard-coded credentials in your source code, I think it's important to recognize that this is something that we probably all have done. We probably all do. I've done this recently. You know, you want to test out an API, you grab the API key, you just chuck it in your code. You're like, oh yes, it needs to go in there. This is bad, right? This is a red flag. If you see this in source code somewhere, you need to do something about that immediately. You don't want these hanging around in your source code uploaded to GitHub where someone can find them and do something bad with them. So generally what happens is pretty much immediately, hopefully before you check it into GitHub, you're going to move those out into, at the very least, environment variables so that they're no longer in your code. You're managing them somewhere else. So this brings us to the foundations of secrets management. What are these are the things that are sort of non-negotiable. They're things that you need to do to be able to secure secrets. The first one is encryption. If your secrets are sitting around in plain text on disk, either on your local workstation or in your Git repo, whether it's GitHub or GitLab or wherever they need to be encrypted, right? Hopefully they're not sitting around on your local workstation if they're production secrets, but wherever they are, if where we're storing them, we should be storing them encrypted. And in transit as well, if we're moving them around. Maybe you have a central secrets management and you have servers retrieving those, that connection should be encrypted too. The second one is backups. More importantly than backups, being able to restore in case that your secrets management system goes down or however you're storing those secrets. You need to be able to get them back. Now, I will caveat that with, if it's something that you can regenerate, like an AWS access key, probably don't need to back it up because you can just regenerate it. But you need to go through and make sure that you have a plan that if someone deletes it by accident, that you know how to recreate that. And the third one is having policies and guidelines. As an organization, it's really hard to try and tell people, hey, you need to do good secrets management, unless you're actually telling them what you mean by that. Not just policies that an auditor will look at and say, yes, you're doing good security, but actually something that's easy for developers to read and understand, and all of the teams across the organization to understand what you're expecting of them. So coming back to our path of improvement, everything else we're going to talk about on this path is good. So we're going to draw a line there and say plain text hard-coded secrets are bad, and everything else that we're going to talk about is good territory. We're going to get better as we go, but even some of the basic tools that you can use to protect your secrets are going to be a lot better than just plain text hard-coded secrets. And the first one that I've often given people as like here's a way forward is Mozilla's SOPs tool. It's a pretty straightforward tool. It allows you to use asymmetric cryptography. So you generate a private key on the server, the private key stays on the server. Your public key you can use to encrypt the secrets that server is going to need, and you can put them in source control. You can put them in GitHub, because at this point they're encrypted. in a way that only the server is going to be able to decrypt. Sealed Secrets is another great project. It does pretty much the same thing, but specifically for Kubernetes environments. Cool. Those tools are also going to cover the core goals, so we should probably look at those now. The first one is high availability, especially if you're thinking about you're putting in something that your whole organization is going to use to manage their secrets. Or your entire organization's availability, every single one of your applications is going to be relying on being able to retrieve those secrets. You know, every time it auto scales or a container restarts, or however it is that you manage your applications, if your secrets aren't accessible, those applications won't be able to function. So however you manage them, those secrets need to be highly available. The second one is centralize and stabilize. So if you're part of the security team, you probably recognize that if you have, say, 50 application teams that are all storing their secrets in different places or managing them in different ways, it's going to be really difficult for you to go through and make sure that they're being rotated, you know, that they haven't been compromised, things like that. So having one way of doing things, or it might not be one way, you know, you might have some servers on-premise that need a different way of handling things from your workloads in the cloud. But you want to have a paved path, a way of doing things so that everyone's on the same track, and it makes it easier for you to see across the board how everyone's managing their secrets properly. And the other one is stabilize. If you're changing the way that you want people to store their secrets every 3 months, it's going to be harder to convince people to adopt that approach. It's going to be harder to centralize it if you're changing it all the time. So trying to keep it stable so that everyone knows what the expectations are and they know that if I put the work in now, that's going to serve me well for quite a long time. And the third one is least privilege access. So least privilege access is a pretty common concept in information security. It's all about making sure that we don't open things up more than they need to be. And there's a few facets to that. So one is we talked about these are machine-to-machine credentials. And I'm convinced that for most of the time, at least, but pretty much all the time, humans don't need to be able to access those secrets. So they might need to manage them, they might need to rotate them, create new ones, but they hardly ever need to actually go in and retrieve that secret. Every application should have its own secrets. So if multiple applications are accessing the same table on the same database, they should still each have their own access token for that database. I've certainly been responsible for rotating an access token that I thought was for one application, but another application was using it as well, and things went wrong. So you want each application to have their own secret. Along with that comes making sure that the application only has access to the things that it needs. Again, with the database example, if you have multiple database tables and the application only needs access to one of them, only give it access to that one. If each application has its own secrets, that means each application can have access to the database tables it needs. And the last one is they should really only be for one environment. Like, don't share secrets across test, UAT, production, because you probably have different access requirements there and different levels of who can access those secrets, right? Developers might need access to test secrets, but they certainly shouldn't need access to the production ones. And the other thing is where you put those. So if we think about how we deploy applications these days, you probably have some source code. You might have some infrastructure as code in a separate repository, build pipelines, some sort of repository that you put those artifacts in, and then a pipeline that deploys them onto various servers. Well, if you store your secrets in source code, your secrets are now in the source code, they're in the build pipeline, they're in your artifacts, they're in the deploy pipeline, and they're on your servers. If you can get to the point where the servers pull the secrets themselves when they start up, there's a lot less room for someone to get hold of those secrets because they're only in one place. So that all comes under that least privilege access. And SOPs and sealed secrets and those tools will get most of those, will get you through most of those goals, at least to a sufficient level. Obviously with SOPs, you are still probably putting those secrets in source code, but only the server can actually decrypt and access those. If we move on to some of the more advanced use cases from there, you might look at something like a platform integrated solution. So in AWS, that's Secrets Manager. In GCP, it's also Secrets Manager. In Azure, it's Key Vault, because they wanted to name things differently. And also in AWS, Parameter Store will get you most of the way there to most of these things. Doesn't have quite the same level of automation, but it can be a little bit cheaper. And those will also cover most of these goals. They're easy to implement because they're usually a managed service. You know, so your secret is just an API call away. There is a little bit of cost involved, and if you're on a single platform, they'll do most of what you want, including some of the things that we're going to talk about next, which is some of the more advanced use cases. They're really good if you're using managed databases and things, because they often integrate and allow you to manage those secrets without having to manually go and rotate them and things like that. So I guess we should probably talk about some of those more advanced goals. The first one is auditing, audit logs. Now, that tool that I talked about, SOPs, before, because the secrets are sort of kept with your source code and not managed centrally, you're not going to get that auditing. So you do need a more central system to be able to log everything. But being able to know when was the last time someone accessed this secret. You know, I've worked with an organization where they had a great centralized tool and nobody ever looked at the reports. I looked at the reports. Half of these secrets haven't been accessed in 5 years. Are we sure we still need those database users? Turns out we don't. So having that visibility of, in your secrets management tool, being able to see them all, being able to see when they were last accessed. Also coming back to our InfoSec goal of maybe being able to figure out how we got compromised, being able to see when someone who wasn't meant to retrieved a secret is helpful in that use case. Often it's not just about your secrets management platform either, it's also about those downstream systems. If you can get your database server to tell you every time a database user was used, that can also feed into that logging. The second one is lifecycle management. So now we're getting into some of the more advanced things, right? So lifecycle management is all about how we manage our secrets. We're not talking about automation yet though, we're just talking about having some sort of process that we follow and hopefully some sort of spreadsheet or database somewhere where we document when these things happen so that we know that we're creating our secrets in a way that follows our policies. That they're long enough, they're complex enough, that they're not going to get guessed, for example. We're talking about machine-to-machine secrets, so these definitely don't need to be things that users are able to read and type in. Storage, we're talking about secrets management platforms, so we're always going to have somewhere to store them, but knowing where they are stored is useful. And then being able to have managing the lifecycle of those keys. So knowing that we want to rotate these keys every 30 days, so let's track them and make sure that we do actually rotate them every 30 days, or whatever you decide is how often you want to rotate them. And the final one is revocation. So for example, if your keys get compromised, making sure that you have a way that you can easily revoke them. And the same with if you rotate them, making sure that those old keys stop working. And then finally, we move on to automation. So it's all of those concepts again, how we create them, how we store them, how we rotate them, and how we revoke them. But now we're starting to add automation so that we don't have to manually go and rotate those database credentials every 30 days. It just happens. And when you automate some of these things, now we're talking about, well, we can rotate database credentials every half hour because it's done automatically for us. We don't have to worry about it. And these are the more advanced goals. They're still really important, especially if you're a larger organization. But they're sort of the things that you start to think about once you've got those core goals down. So if we continue on this road of improvement, and maybe we're using multiple platforms, maybe we still have some on-premise stuff, we have secrets we need to keep in multiple places, that's when we start to look at some tools like multi-platform vaults. So I use HashiCorp Vault a lot, so I use that icon. There are multiple services that'll do a sort of secret vault type service that runs across all of your platforms. That's not to say you can't use, say, AWS Secrets Manager across multiple platforms, but some of these vault tools will help you automate things across all of your platforms. And then finally, workload identity is sort of the end goal, right? The gold standard for secrets management. And the thing with workload identity is you don't have secrets anymore. Like we sort of, by the time we get to workload identity, and I'll say this now, my colleagues Mario and Eamon are giving a talk tomorrow on workload identity, specifically Spiffy and Spire. But there's a lot of ways of, especially, each cloud platform also has their own way of doing workload identity, of your applications automatically getting some sort of identity that they can use to authenticate themselves against a database, rather than having to have a database credential. Cool. Carrying on. Okay, so this is a summary of all of the goals. Like I said, I've based this on the OWASP Secrets Management cheat sheet, and that goes into a lot more detail on each of these points and how you might go about implementing them. The final thing I'm going to talk about is a developer perspective, because, and I'm guilty of this too sometimes. I work a lot on the infrastructure side, on the platform side, and we talk about implementing these things. We don't necessarily think about how it's going to impact applications, how developers are going to deal with the fact that the database credentials are changing underneath them every half an hour. So let's talk a little bit about that. So one of the things is that there's still, these days, environment variables aren't necessarily the best ways to store credentials or to pass credentials to an application. In a lot of environments, it's more secure to have some sort of memory-backed file that you use to pass the application its secrets, and then it can read it out, delete the file, and the only place that that secret then lives is in the memory of the application. There's been a lot of exploits in the last couple of years with being able to read out all the environment variables of an application, and if your secrets are in those environment variables, then they're compromised. So when we talk about application startup, we need to obtain the secret securely, and depending on where you are, where your application's running, that'll differ, whether you need to make a network call out to a secrets management platform or whether that's been passed into you and you can just read it in at startup. But it is a thing that the application needs to be told how to do, right? And then we're going to load the secret into memory. As I said, ideally we want that secret for the majority of its life to just live in the application's memory. And hopefully, if we can, as a stretch goal, we're going to destroy wherever we got that secret from. So for example, if we're passing it in as a file, we're going to read the secret out of that file from disk, and then we're going to delete the file because we have it in memory now. Now, there are some other considerations with that, because if we need to reload the application for some reason, we've deleted that secret. So you need to have some mechanism for retrieving a new secret. The other one is secret rotation. So some people get a bit nervous when I say rotate database credentials every half hour. And that I am over-exaggerating it just a little bit. But a lot of applications don't cope with losing their database credentials in the middle of running, right? So there's two ways of doing database credential rotation, or secrets rotation in general. One is single user, and the other one's dual user. And it could be dual users, it could be two keys, either one or two. So if your application supports it, and if your database supports it. This is an area where you need to know how where you're getting the secrets from behaves. So for example, Postgres, I believe, will keep your session up. So if you have an existing connection and you change the database credential for that connection's using, you can keep querying that connection. It's only when you disconnect and try to establish a new connection that it will require that new secret. Whereas most of the other database applications will drop any connections using the old secret as soon as you rotate it. So how's your application going to behave when you rotate the secret out from under it? If it's not possible to do it with a single user or a single secret, then you might have to adopt an approach where you have two users. And that way you can generate a new user with a new credential while the application's happily using the old one. You can do whatever process it is that you need to do to get that new secret out to your application. And once the application has started using that new secret, then you can drop the old one, which is a bit more difficult from a platform point of view. But if you're assuming that all your applications can just do it with a single user and they'll be fine with keys rotating out from under them, you might be in for a shock when you try and get your applications to use it. So yeah, from a developer's perspective, these are the sort of things that we sometimes don't think about, is how is the application going to cope with this new secrets management mechanism that we want to use. Cool. This is a summary of, that's all the links to all the tools. So I highly recommend checking out the OWASP secrets management cheat sheet, and just generally all of the OWASP resources are pretty awesome. Mozilla SOPs is a great way to improve secrets management if you have little to no secrets management in an application to start with. Highly recommend just using your platform's built-in secrets management tools. They're often really good, and if you're in one platform, that's probably all you need. And then obviously there's HashiCorp Vault, there's Spiffy and Spire, which are the open source workload identity tools, but there's also a bunch of different workload identity tools in different platforms as well. And the last one, there's the link to the article on why environment variables for storing secrets aren't necessarily the best thing. And that QR code will get you to the slides and all of that stuff. And, Eamon and Mario, like I said, are speaking more about workload identity tomorrow if you want to hear more about that. Awesome. And that's me. Yeah, sure. Yeah.
If anyone has a question for Olly, you feel free to put your hand up and someone will come around with the mic. Any questions?
So I'm guessing it will depend a bit, but do you ever get any questions when you're implementing this about more specifics about key management, like if people should be using HSMs or key encrypting keys or anything like that, or is it more just trust the tool? Because you're sort of just pushing all the secrets from a lot of different places into one central, really interesting place for an attacker, right?
Can you hear me? Yes, cool. Yeah, I guess it depends. I've worked with different teams that are at different stages of that process, and sometimes it depends on, if you're in a highly regulated environment and you need to have your secrets be in an HSM, then that's a consideration. Often when I'm thinking about moving further right on that spectrum, that's where, how far do you need to go to be able to achieve all the things you want to achieve? But yeah, more often I'm thinking about how are we improving things? But certainly if you have things in one central location, then that's going to become a really interesting place for an attacker to get to, and you need to, consider how you're protecting that central place.
Excellent. Are there any other questions? Got time for one more? Off the back.
Run.
I was just wondering if you had any comments on integrating knowledge base with secrets management. In particular, the more you segregate how many secrets you have for every single little thing you're doing, documenting that becomes more and more important, and that documentation becomes a big target for attackers. Yeah, so I was just wondering if you had any comments on that.
Yeah, that's a good question. I guess you probably shouldn't rely on if you're documenting, you know, which secrets you have and where they are and that sort of thing. You should probably. I'd be concerned if the documentation is a vector for getting those. I get what you mean about, you know, the more you understand about the environment, the easier it is for you to then go and compromise those things. But yeah, I think you shouldn't be not documenting things just because you're concerned. Is that what you mean?
No, more as to, would you segregate document in any way, or would you have any specific requirements or rules for how you will document what a secret key does and what its purpose is?
Right. I don't know. I haven't really thought about that. I think most of the time I lean on the side of I'd rather that we share that information internally. Like obviously, if it gets out, that's not great. But I tend to lean towards the side of everyone should be able to access the documentation, because it's probably better that people understand what the different things do than to try and prevent someone externally from understanding that. Yeah.
Awesome. Well, thank you, Ollie, for speaking to us. We have a thank you gift for you. Thank you very much.